In the world of quantitative finance with Python, Numpy plays a pivotal role. And in this single video, we're going to learn everything we might need about Numpy in our algo trading journey. Hello mini traders, and welcome back to another video of our comprehensive algo trading course. In this video, we're going to talk about Numpy. Numpy is a free module for numerical calculations, which helps us do our calculations fast and efficient with the great tools it has for array handling. This library has also functions for handling matrices, which are vastly used when we are working with price charts and candles. Numpy arrays are much faster than the basic lists of Python. First of all, we need to install our Numpy module. In most of versions of Anaconda, it has been installed by default. But if you need to install, you can use pip or conda, as we have previously discussed in Python modules video. After installation, we can use Numpy by importing it, and like most of the other programmers, we can rename it into NP for easier usage. In this example, we have used Numpy to create an array. We can use Numpy for calculations of scalars, vectors, matrices, and so on. This range of difference needs a specification called dimension. Each Numpy array has dimension. Dimension 0 is for a scalar, dimension 1 is for vector, dimension 2 is for matrices, and we can even define higher dimensions. We can see the dimensions of an array using ndim function. Pause the video to see what is the difference between the data structure in different dimensions. We can also define the number of dimensions in an array using ndim argument. For example, we have defined an array with the dimension of 5 using a vector. Look how the structure of our vector has changed from 1 dimension to 5 dimensions. Now, after defining arrays, we need to be able to access each element. This is possible using indexes for each element. Let me explain it with some examples. We have defined an array with 1 dimension. For accessing each element of this array, we can use a number between 0 to the length of the array minus 1. 0 is the index of first element. You can see the number of each element in our example. For more than 1 dimension, we access elements step by step from the highest dimension to the lowest. Look at the example to see this selection. In the example, you see a 3D array. It has 2 elements. Index 0 selects the first element. The first element has 2 inner elements. And the index 1 would select the second element, and finally it has 3 inner elements, and the index 2 would select the third element, which is number 6. For better understanding, test it after downloading this file from the description with other indexes. We can also use negative indexing to access the elements from the end. Minus 1 is the last element. In the example, first we selected the second element and then the last element of the inner array. Sometimes we just need specific parts of our array. This is where we need array slicing. Slicing means taking elements from one given index to another. Slicing is similar to accessing the array elements. In the first example, we have accessed elements from index 2 to 4. Notice that the last number in the range would be excluded. The structure is mentioned in the comment. We can also leave the start or the end empty. This way, the slicing would be started from 0 or it will continue to the end. We can use negative slicing in case of need. In the example, you can see that we have started slicing from third last element to the second last element. We can use steps for slicing. In the example, you can see the structure and how it works. With the steps of 2, our slicing would pass one element after considering 1. With the steps of 3, there will be 2 elements between the selected elements. You can test it as a practice with other arrays and steps. Now we need to know 2 different methods of duplication of arrays and their differences: copy and view. Let me explain in the example. As you see, we have 2 examples of duplications of an array. In one of them, we have used copy method, and in the other, we have used view method. Then we have called both original and duplicated arrays. As you can see, in copy method, the duplicated array owns its data, and any changes made on one of the arrays will not affect the other. While in view method, the duplicated array does not own the data, and any changes in each of arrays will change the other. Both of methods are being used in programming, and you have to know the concept of this kind of difference. Now let's see what is shape of array. The shape of array is the number of elements in each dimension. You can see this attribute for 2 arrays. This will return a tuple. The number of elements in this tuple is equal to the number of dimensions the array has. Let's decode the elements. The shape of array 1 tells us that it has 2 elements in its first dimension, and it has 4 elements in its second dimension. The shape of array 2 shows that this array has only 1 element in its first, second, and third dimension, while it has 4 elements in the last dimension. For better understanding this, I suggest you to make different arrays with different numbers of elements in each dimension to see the results. Most of the time, we check the shape of our arrays to see if we have the right array when our array has lots of data and the data is not being shown well. Numpy allows us to change the shape of arrays as we need. This is possible with the Reshape function. In the example, you can see that we have changed a one-dimension array into a 2D and 3D arrays with our specific shape. Note that we cannot change the shape without considering the elements of our array. That will raise errors. The other consideration which must be applied about Reshape is that you have a view of your array and it's not a copy, and the differences between are the same as we have talked in this video. In many cases, you would need to have some freedom in changing the shape. In these cases, you can leave one of the arguments of Reshape to the Numpy to decide about. This is possible using -1 in the argument. As you can see in the example, we have defined that we need 3 elements in its first dimension, and Numpy decided that we would need 2 elements in the second dimension. Lots of the times we have multi-dimension data which is not needed to be multi-dimension, and we just need the numbers. In these cases, we can flatten the array into 1 dimension using Reshape -1. We have talked about iteration in our previous videos. The iteration might be confusing in multidimensional arrays, so let's take a look at some examples for understanding it. First, we start with a simple 1-dimension array. As you see, iteration is possible using a for loop, and it will iterate elements 1 by 1. Now if we use a for loop for a 2D array, it will iterate only the elements of first dimension one by one. For reaching inner elements, we should use nested for loops, and this is available for more than 2 dimensions too. There are more advanced ways of iteration in NumPy, and we might explain them if we need, but for now this basic iteration is enough. We can use Concatenate function to add an array data into another. Joining in 1D arrays is simple, as you can see in the example. But when it comes about 2D arrays, we have a concept in name of access, and you can see how access works in joining arrays. If you don't specify access in the function, it would be 0 by default. Now, what if we need to split one array into several? This is possible with array split function. As you can see in the first example, we have a 1D array with 6 elements, and we split it into 3 arrays. The return value is a list included 3 arrays, each containing 2 elements. If we need to access each array, we can call it as a member of a list with its index number. In the second example, we have split the array into 4, and as the elements was not enough for doing this, the function adjusted the number of elements each array must have. Splitting to the arrays is the same with one difference. This time, you can also define access for splitting. You can see the results in 2 examples. Sometimes we might need to sort our arrays. This is possible using sort method. You can see 2 examples of how it works. This method can be used for other data types too, and the return value is a copy of the array, and the original will remain unchanged. We can also search inside our arrays. The search can be done using specific value or a specific condition. In the first example, we have searched for the value 3, and the result is a tuple of indexes which indicates the places where number 3 exists. In the second example, we have searched our array for even numbers by defining a condition. The last thing that we are going to talk about is filtering arrays. Filtering means extracting some of the elements of an existing array and create another array with these elements. We can do this using a Boolean index list. For better understanding, let's see the example. First, we have defined our array, and then we have the Boolean index list. When we apply the filter, the new array would have the indexes 0 and 2, which are 11 and 33 in this case. In the next example, we want to make our Boolean index list using some condition. In this example, we want to have even numbers in our new array. So as we said, we need an empty list. Then by iterating through the first array, we make our Boolean index list, and then we can filter our arrays using this list. That's it for this video about NumPy. I tried to cover the most important parts of this module, but of course this is not the all capabilities of this powerful module. I put the link of the documentation of this module in the description of this video, so you can find the answer for every question you might have about this module. Don't forget to practice what you've learned in this video, and for more videos of this kind, hit the subscribe button and the notification bell, as we are getting into more advanced levels of algo trading. Thanks for watching, have a good time, and